Good morning, and we are live for day 8 of Space News. Thanks for joining in. My name's Mike. I read the news. I read the space, so you don't have to. I read the news, so you don't have to. Let's jump into this article about the NASA Ingenuity by Eric Berger. It's a follow-up from what we did on day 7. I'm sure we'll make it quick. So it turns out that NASA's Mars helicopter, Ingenuity, was more revolutionary than we knew. It packed more computing power than all other NASA deep space missions combined. Cool. All right. How so? So in the image, we see the four-blade helicopter with its four landing legs. So this is an interesting shot. It looks to be taken from the ground. Or actually, it's a shot from Ingenuity looking down at the surface of Mars, and that's its shadow. Very cool. Okay, so it's been dubbed the little mission that could. This was a very small helicopter, and I'm sure they would have been totally happy if it didn't even work. Well, happy's not the wrong word, but they would have been totally happy getting less information than they did from this craft. It wasn't meant to be the primary mission, and it ended up flying 72 sorties across the planet. Okay, so let's look through. Though its carbon fiber blades will spin no more, its work has only just begun. Ingenuity was groundbreaking in two significant ways that will ripple through the culture of NASA. Although it is impossible to know the future, both of these impacts seem overwhelmingly positive for our efforts to divine the secrets of our solar system. First of all, and most obvious, NASA has now demonstrated that powered flight is possible. It's no longer a theoretical, it's grounded in reality. Okay, words. Oh, this is cool. In another, arguably more important way, Ingenuity changed the way NASA. Ingenuity changed the way it selects hardware. The program was able to operate. The helicopter was built so by using commercial off-the-shelf parts. This is a big change up from NASA, I think, really leans on building a lot of their own components and devices, and everything they purchase is rigorously tested. If you want to send something to space, typically you want to have exposed it to some radiation, so run it through something like a Cobalt-60 test. You'll want to have exposed it to the lows and the highs, the extreme temperatures that you will experience in space. It needs to be vibration tested because during launch, you have this device on a rocket that's shaking very violently. So requiring all of those tests to be run on your on these individual components that you keep building is difficult. If you can buy, let's say, a computer that's all-in-one off the shelf, and you know that it's experienced or gone through all of these phases of testing, then it'll be easier for you to build. You can mass manufacture easier. You just need to shell out a little more money, and you have what you want. All right, the scientists and engineers who built the helicopter had no choice. Flying on Mars is incredibly demanding. The air is so thin that it is equivalent to flying at an elevation of 80,000 feet on Earth. So to put that in perspective, your commercial aircraft will fly at about 40,000 feet. That's your 747s, your jetliners, or 3 times higher than the peak of Mount Everest. Helicopters on Earth can max out at an altitude of 25,000 feet before the air is too thin to support the rotation of their blades. To meet the demands of Mars, Ingenuity's designers had to be ruthless in their choices. They could not afford the mass of radiation-hardened components. Okay, like for batteries and computers. Okay, I'm starting to suspect that they had some thick aluminum or thick metal that gave the same radiation deflecting properties as aluminum, but had lower density. So they bought commercially available parts and rolled the dice with astonishing results. Many NASA missions will never be the same. So during a news conference on Thursday afternoon, Glaze and other NASA officials drew a comparison between Ingenuity and the 1903 Wright Flyer, the first aircraft to ever be airborne. This, built by the Wrights, this experimental aircraft made the first powered flight. Yes. It achieved a distance of 852 feet on its final flight from December 17th, 1903. After landing, high winds blew the airplane over and wrecked the vehicle. Well, I think the pilot was okay. I haven't heard anything in my history classes about one of the Wright brothers dying in their last flight, so it was just the aircraft that experienced some damage. On Mars, Ingenuity became the first vehicle to demonstrate powered flight on another planet. Okay. Talks about World War I. As a Mars scientist, I dream of a helicopter exploring the canyons of Valles Marineris. Beautiful name. She's this is Lori Leshin, the director of JPL. The type of mobility can take us to places that we never dreamed we'd be able to explore, and the possibilities are endless. Valles Marineris is the largest canyon in the solar system, measuring 4,000 kilometers and running more than 7 kilometers deep. I'm curious, how big is the Grand Canyon? Okay, so the Grand Canyon is 446 kilometers long and 29, how deep? And about 2 kilometers deep. So this canyon is much, much larger. 4,000 kilometers, 10x the length, and 3x the depth. And think, if any of you have been to the Grand Canyon, that first view when you stop your vehicle, you get out, and you start to walk towards the edge. At least when I was there, it was all clouds, so we couldn't see down into the canyon. So we just started walking and walking and walking, and about an hour in, we got below the cloud line, and I don't recall exactly what image would fit, but it took your breath away. Absolutely beautiful location. All right, we have half an article left. So NASA has been big plans for other flying machines. Next, it's looking at the Dragonfly mission to Titan, one of Saturn's moons. The vehicle, which the Johns Hopkins Applied Physics Laboratory in Maryland will build and operate, is scheduled to launch in 2028. So it's an automobile-sized, nuclear-powered drone. Jesus. Over the organic-rich sands on Titan. There are some advantages to flying on Titan. Its primarily nitrogen atmosphere is about 50% thicker than Earth's at the surface. Okay, so the blades will have more to grab onto. But even so, developing and flying such a large vehicle in a relatively unknown environment represents a huge challenge, of course. That's a cool rendition. That's very futuristic. 6 blades, 8 rotors. I mean, I only see 2 hands, so I would assume 2 hands on the left, 2 hands on the right, 4 rotors. Okay, some more fist pumping. It will be able, the Dragonfly, this new helicopter will be able to carry a heavier payload, and it will be able to spin up to almost the speed of sound. That's the rotor speed. Yeah. What are the limits? More fist pumping. So they talk about the thin atmosphere of Mars. So some planetary scientists have long dreamed of deploying a balloon or simical in the atmosphere of Venus, Venusian. Near the surface of the hellishly hot world, the atmosphere is crushing, but higher up there are atmospheric pressures closer to Earth. Each world represents its own challenges. Mars's atmosphere is exceedingly thin, but is offset by the reduction of the gravitational force, which is about 1/3 of what you would experience on Earth. This makes technologies like fixed-wing aircraft and other flying machines more possible. Okay. And then they talk about base camps and using drones to survey terrain, survey terrain. Wow. Terrain. Buying commercial works. As cool as Ingenuity's flight log, ooh, we can peek at their flight log, maybe the better story is how the engineers at JPL did it. Due to the aforementioned thin atmosphere, the team was constrained to a mass of less than 2 kilo. That is equivalent to approximately 5 cans of Campbell's soup. These 5 cans of soup include your blades, the batteries, the computer, the sensors, the cameras, the legs, the solar panel, all of it. So how did they do it? They ditched traditional space-rated hardware. They couldn't just take the mass penalty. For example, the RAD 750 computer, which I believe is developed by a British company. Yeah, it's developed by BAE Systems, who's a British hardware manufacturer. Oh, am I wrong? Headquarters is in the US. Tis American. Anyways, for that computer, the RAD 750 weighs more than 1 pound. They couldn't blow that much mass in a computer, and they instead opted with a smartphone computer chip, the Qualcomm Snapdragon. Wow. So it was the Qualcomm processor was something like 20 years of progress compared to the original RAD 750 that they had been operating with, that NASA typically puts in its vehicles. In addition to being orders of magnitude, it's also cheaper. The RAD 750 is about $250,000, whereas the Qualcomm goes into inexpensive mobile phones. Okay, so it has to be less than $1,000. That's what they're saying. I'm not sure if you'd actually get it for less than $1,000 if you're purchasing 5 of them versus 50,000 or 500,000 like you would if you're Apple. But we give them the benefit of the doubt. It's still cheaper than 250,000. So a similar philosophy, where it was not a non-radiation hardened philosophy, went into other components such as the rechargeable batteries on board. These are similar to lithium batteries sold in power tools at hardware stores. Lithium hates temperature cycles, and on the surface of Mars, they would be put down through a hellish cycle of temperatures from minus 90 C to plus 20 C. The miracle of Ingenuity is that all of these commercially bought off-the-shelf components worked. Radiation didn't fry the computer, the thermal cycles didn't destroy the battery storage capacity, and likewise, the avionics, sensors, cameras all did not produce any problems despite not being space rated. Very cool. So NASA obviously won't be ditching space-rated components, but it does open a pathway and this is a good point of discussion for newer companies that are trying to build their own crafts. You can always skip the space-rated components and purchase commercially available off the shelf. It's cheaper. It will get to you sooner. If you want to buy space-rated components, you often need to wait months for delivery times of your engineering models and flight models. You just need to weigh that against the risk that this device that's never operated in the new environment of space will not break on you. And if you're a new company and you only have 1 or 2 aerospace vehicles and one of them breaks, is your company going to survive? So NASA has this ideology as well. A lot of their missions are really critical. They spend billions of dollars on developing a vehicle. They can't risk having that vehicle go down because they tried to save a little bit of money on a computer or on a battery pack. So Ingenuity's success opened a new pathway for most science missions. They can be cheaper, lighter, and higher performing in every way. This is almost unimaginably liberating for mission planners. Absolutely. The concept of flying Ingenuity came along just at the right time. Legacy. As a middle-aged space reporter, I've naturally become a little jaded over time as I've watched NASA and other space agencies around the world take 2 steps forward and 1 step back. Space is hard. Battling through bureaucracy is hard. There's a lot of BS out there in the space industry. But Ingenuity has truly taken his breath away. This is Eric's comment. It is a phenomenal engineering achievement. So it is a perilous exercise to judge history while being in the middle of history, of course. But he would rate Ingenuity among the 3 most innovative and important things NASA has done in the 21st century, alongside James Webb and the Commercial Orbital Transportation Service, or COTS program. Interesting. Let's have a look at that. And then there's a picture of... this is a picture taken from James Webb. It is a helium-rich Wolf-Rayet star, generally formed by the ejection of hydrogen and other materials. Beautiful. And I love the stars that surround it in the canvas. Okay, so just a little more on this Commercial Orbital Transportation System. It provided a few $100 million to SpaceX and Orbital Sciences to develop spacecraft to deliver supplies to the ISS. More than that, it is undoubtedly responsible for SpaceX's early growth, and the program and its successors saved the company from bankruptcy. Sometimes government can do the right thing. With NASA's new model for buying services and SpaceX's validation of this approach, this program launched the transformative commercial space era we're enjoying today. That's fair. By demonstrating flight on another planet and cracking the code on off-the-shelf components, Ingenuity easily stands alongside these 2 great achievements. Awesome. Great article. Thank you very much, Eric Berger. And thank you for staying tuned. We will see each other tomorrow. Have a lovely day.